Hi, as we have discussed in the previous video, it's important to have randomly assigned residuals. In other words, it's important to have a model where our error term is not correlated with our independent variables. So in this video, what we will do is we will generate the squared terms and the cross product of our independent variables, and we will we will visualize if the residual is in some way correlated with any of them. First thing what we will learn here is how to generate a new variable in a stata. What you have to type in is g, or the command generate, and then the name you want to assign to the new variable. So first we will generate the square term of price, and we will write down price2 is equal to price square term. Next we will generate the square term of advertising. And we also want to generate the cross product of price and advertising. So you first assign the name of the new variable, and this will equal price times advertising. Great, so now we have generated 3 new variables, and in the next exercise is to check whether one of the independent variables and the new 3 generated variables in some way correlated with the residual. In order to visualize this, the best thing is to run a scatter plot between the residual and the variable. You want to make a quick check if there is some evidence for non-randomness. You have to type in the command scatter, the residual, and then the variable you want to plot the residual against. And first we will do this for price. Just by looking at the graph, there is not a strong evidence that that there is some relation between the price and the residual, and this is what we want in order for assumptions for our usual OLS assumptions to hold. If we repeat this for advertising, we can not be confident that there is a randomness. You can see that there is a good fitted value here, and let's repeat this for the square terms of price. Similarly as the case for price, there is not a strong evidence that there is some correlation. Again, similarly as the plot with advertising, we can see that in this plot the residual is growing with advertising square. And let's repeat the same for the cross term. price, advertising. Luckily here we don't have such a strong evidence. So from this first scatter analysis, we can conclude that when we plot residual against advertising, we can see that the residual is growing with advertising, and this could indicate that there is some various dependency on advertising and can be a good evidence for heteroscedasticity. To get a clearer picture of this relationship, we can plot the squared residual against the independent variables. But before be able to plot them, we have to generate the squared term of the residual. And now we can repeat the exercise from before. And again, I'm sorry. So this is again the scatter of the residual with advertising. So now we want the scatter plot of the square term of the residual. Whenever you see a rat comment, it means that you did something wrong in data. Receipt to great. So once you plot the square term of your residual against the square term of advertising, you can see that this non-randomness becomes more obvious. And this is because when we are looking at these squares, we don't have any negative values, and it is much easier now to see the positive exponential pattern for the square term of advertising. So visualizing is always a good idea, but in the next video we will do a formal test to see if there is some correlation between your residual and one of your independent variables.